Vikas, am I audible?
Hello, yes.
Yes, thank you.
Yeah, Rishabh.
Yes. This is Rishabh.
Yeah, Rishabh, you're audible.
All right, great. Anupma is here also.
Yes, good evening, everyone. Good evening, Vikas sir.
Vikas sir, you can try sharing.
Good evening, Anupama. Good evening.
How are you, sir?
I'm good, thank you.
Okay, thank you for accepting our invitation.
Okay, thank you so much. So we'll start at 6, exactly at 6.
Yes, sir, I'll introduce you and then you can start. Yeah, we'll wait for
Okay.
participants to get
Okay.
by 6.
In the meanwhile, if you
All
want,
right, all
share
right.
your presentation.
So, good evening to all our participants of all ages and of all professions, be it from academia, including esteemed professors, graduates, undergraduates, postgraduates, and research scholars, or be it from industry. So we have to get a scoop of all our participants. So we have people in and around India and also around the world. So firstly, I thank all the participants to join in for our 5 days IEEE Virtual Talk series, which are focused on automation for enabling Industry 4.0. So these 5 day series are basically in order to bridge the gap between industry and academia. So we have treasured to get in speakers from industry to bridge this gap. So I request everyone to kindly firstly mute yourself because otherwise my voice will get echoed. Yeah. So basically this platform we have got brought in to bridge the gap between industry and academia. So we promote interactive sessions. So all the people can directly interact with our speakers in this platform. So with this, I welcome our first speaker of this series. So our first speaker is Mr. Vikas Rastogi, who is currently working with Siemens Limited from last 5 years. He has pursued BTech in electronics and instrumentation and has 14 years experience in industry. So today he'll be talking about Industry 4.0, its components, its requirements. He'll talk about Siemens cloud-based open IoT operating systems, MindSphere, and many other things. So with this brief bio, I request Mr. Vikas for his talk. Over to you, sir.
Okay, thank you, Anupama. And I would request all the participants to turn off their camera or video because it will consume bandwidth. So audio and this my voice will not be clear. So turn off your this camera and your mute your mics. Okay. So good evening, everyone, and I am Vikas from Siemens, and it's been 5 years I'm working with Siemens. So before that, I have worked with Rockwell Automation, then Mitsubishi, and this is my third company. I'm with Siemens from last 5 years. So today we'll talk about Industry 4.0, or you can say it's a fourth industrial revolution. Okay. Okay. I hope my second screen is visible to you.
Yes, sir, it's visible. Perfect. Yes, sir.
Okay. All right. Okay. So first of all, I would like to explain. Yeah, and one thing more. Just whenever you have any question, just interrupt me, unmute your mic, interrupt me and ask questions. Don't wait for the presentation to end to get end, and let's make this webinar more interactive. So if you have any question, any silly question in your mind, just unmute your mic and interrupt me and ask questions. Okay, fine. So industrial 4.0. Okay, so it's basically a fourth industrial revolution. So starting from industry 1.0 and this journey to industry 4.0 or 4.0 you can say. So if we talk about the first industrial revolution, when we start with our machine with mechanization, we use steam power, steam engines. Okay, that was the first industrial revolution we had in India. And in second, when we came across mass production, assembly lines and producing in bulk, production in bulk. So that was the second industrial revolution. Now coming to third industrial revolution was when we introduced PLCs, programming logic controllers, CNCs, and robotics. Okay, so you can say automation, basically automation. So that was a third industrial revolution when we introduced all these things. Now, what is fourth industrial revolution? Okay, fourth industrial revolution is what we talking about the buzzword distillation. Okay, so what we have done in fourth revolution, we have connected all the components of third revolution to internet. Okay, you have heard about IoT, Internet of Things. So this is a subset of this Industry 4.0. There are many, I mean, there are many components of Industry 4.0. Not only distillation, not only IoT, and data analytics, big data. You have heard about all these things. Okay, artificial intelligence, machine learning, then plant simulation, machine simulation. So these are all comes into this fourth industrial revolution. So when we talk about fourth industrial revolution, we talk about data, only data. So when you read about this fourth industrial revolution in newspapers, you'll got to the data is a oil for 21st century. Okay, so data is a oil. I mean, it's a resource. It contains cost. It contains value. Okay, so when we talk about fourth industrial revolution, data will be in center. So how we are analyzing the data, how we are getting deep dive into the data, and getting analytics, getting some meaningful out of it. For example, you are using, for example, I'll say you are using this Google Maps. Okay, so when you use Google Maps and when you are navigating to some place, your home to your office, so continuously you are sending data to cloud. Okay, data is being analyzed in cloud, and the same time you are receiving the data, analyzed data on your mobile phone. Okay, so you get your speed, your vehicle speed, your current location, and your traffic status. Okay, so this is called data analytics. So continuously you are sending data to cloud, it is being analyzed in there, and you're getting the data, analyzed data on your mobile phone. Okay, so this is data analytics, a best example of data analytics. Okay, so all about data. When we talk about fourth industrial revolution, we'll talk about data, IoT, IIoT. So IoT is Internet of Things. You must have heard about this Internet of Things. So we are getting AC is now connected to internet. Your washing machines are connected to internet, and what else? Your car vehicles, four-wheelers are connected to internet. Okay, what else? Your smart homes, your homes are connected to internet. So this is all comes in IoT, Internet of Things, simple, which we are doing for just for our convenience. But when we talk about IIoT, that is Industrial Internet of Things. Okay, so picture get changed. We have to look about security reasons, IT security, and data, so that data nobody can hack the data. Nobody can, take the data. So all these things we have to consider when we talk about internet. Industrial Internet of Things. Okay, then we come off simulation. So now what we are doing in industries, any industry you go in, textile, in food and beverages, and in rubber industry, tire industry, okay, in vehicle industry. So what we are doing, before a product coming into a real world, we design its virtual copy in our system, in a laptop, in a desktop. Okay, simulate it with PLC, program it with PLC, check it that how it's performing. Okay, before it's in a laptop, a virtual copy, or you can say a digital twin. We call it in industry, we call it digital twin, or you can say a digital copy. Okay, so rather than doing or giving that product, first coming that product into a physical world, we design it, we commission it, we program it in a virtual world. Okay, we test it, how it works, its efficiency. Okay, and when get product get, when that product get fit or as per your usage, you give your to your maintenance team or your manufacturer team to start manufacturing the product. Okay, so that this thing also comes in fourth industrial revolution. We call it virtual commissioning. Okay, we call it virtual commissioning in industry world. So fourth industrial revolution is a just a basic term, and all these things come into fourth industrial revolution. Now we you on big data analytics. Big data means tremendous amount of data you have to analyze. Okay, you have seen, for example, some of you or all of you have seen Excel sheet or Excel file of in KBs. Now, what if you're getting an Excel file in GBs? So big data, we talk about big data. So we have to analyze that data. We have to keep that data at some place, use it in the future. So all these things, big data analytics comes into fourth industrial revolution. Okay, fine. So let's move forward. I think to all of you, fourth industrial revolution is clear till now. Okay, right. So IoT, as I said, it's the Internet of Things, and it is the biggest enabler of this distillation. Okay, biggest enabler of distillation. So when we talk about IoT, it started between 2009. And the IoT incepted between 2009. It's a survey, just a survey done by some company. So it was started in 2009, and till 2020, by the end of 2020, we are expecting 50 billion devices will be connected to internet. Okay, just a survey, just to show that how exponentially these devices are connected in the graph. Okay, fine. Okay, so next slide about cloud computing. So many of you must be aware of this cloud computing, why it is required, why it came into existence. So earlier in enterprises or any factories, factory used to maintain their own servers to store their data, to store SAP data, to store ERP, CRM, what else. So earlier, before this concept came into picture, all the factories and enterprises, they maintain their own servers, their server rooms. Okay, then IT guys, they maintain their IT people. But when this cloud computing came into picture, cloud computing is nothing but we are using remote servers to compute and networking to store the data for database for application services. So cloud computing is just using remote servers rather than using own servers and maintaining it and spending money on maintaining all these IT rooms and IT team. So concept came in cloud computing. So rather than giving all these things, we give all these headache to these cloud providers. So cloud computing is nothing, just using remote servers for all these things, computing and networking, storage, database, application services. Okay, so cloud is nothing but a server, you can say, where you can put your data. Fine. Okay, so this is another survey done for IoT. Like why industrial enterprises are deploying the IoT? Why? फायदा क्या है? Why to spend on IoT? So, and then this research or this survey came out, data came out that it increased sales to 31%. Okay, it developed or enhanced the product to 41%. It reduced the risk to 67%. Okay, and optimized the operation to 73%. Whenever you go to Facebook, you buy a shoe. Okay, for example, you buy a shoe on your Facebook, and next time when you go to a Facebook, okay, you will see all the options of upcoming or latest shoes. Okay, so that machine learn your preference, your search preference, the search engine behind Facebook, learning your preference, your search preference, and giving you the data in front of your screen. And it happens to all of you, any site. Okay, whenever you're looking for any shoe, any apparel, or anything you are looking on there. So after some time, when you log into that app or that website again, you will see a hell lot of not examples, hell lot of advertisement regarding your preference searches. So it gives an increase in sales, and it increases sales. Okay, so same. So developing and enhancing the products, it reduces the risk, optimize operations. So these are all happen in the industry after they go for deploying the IoT. Okay, fine. So for example, machine learning. You heard about this term, machine learning. So giving data to machine. Yeah, you're giving intelligence to your machine so that before they start up, they speak to you that my bearing is now not in a condition to run upon, or do this maintenance activity before I go into shutdown. So we are moving towards that direction. The machine will tell us that today is my healthy status is this, my whatever, my bearing, my gearboxes, my cams are not working properly. Just go and maintain it first, then start. Okay, so we are heading towards that direction. Okay, fine. Right. So this screen in front of you. Okay, so these are three platforms. So very basic and very important slide. These are three basic platforms present in market. Okay, any question, just interrupt me. I'll answer it. So these are three basic platforms, or you can say cloud platforms available in market. Starting from software as a service, then platform as a service, we call it PaaS. Then infrastructure as a service, we call it IaaS. Okay? So first one, software as a service, SaaS, you can say. SaaS. So we are all using it. SaaS, we are all using it. Or in fact, I must say misusing it. Okay. So Facebook, WhatsApp, Instagram, what else? Gmail and Twitter. Okay. We are all using it. Okay. So these are all software as a service we are using. You are not bothered about networking, servers, storage, what you see in dark boxes, these boxes below. Applications, data, runtime, middleware, OS, and virtualization. You are not worried about all these things. You are just using software as a service. When you when you share any video, Anupama, I am getting this, sorry to interrupt, I am getting annotation request repeatedly. What is it?
Please ignore
sir,
it.
maybe it's like,
Okay,
yeah,
so
please
ignore
ignore.
shall I decline it?
Yes,
Okay.
sir. Maybe
Yes,
someone
sir, decline it.
by mistake clicking on the screen. So you please decline it.
Right. Okay. Done. So software service we all are using. Okay. All the apps on we are using on our iPads, on your mobile. So we are all using we are just using as a software. when we share any video on WhatsApp, we are not concerned where that video is going, where that data or video is supposed to store. Okay, we are just not bother about it. Okay, we are just using software as service. So all these things, networking, server, storage, virtualization, operating system, middleware, runtime, data applications are all we are not worry about. Now we come to platform as a service. My voice is echoing. I think somebody has unmuted his mic.
Yeah, I request everyone to turn.
Right. So when we come to PaaS, platform as a service, so only data and application we can manage or we can customize. Okay, rest all networking, server, storage, operating system, middleware, runtime will be monitored or will be managed by the party or by the company. So Siemens is here. So Siemens has a cloud. Okay, Siemens has its own cloud, which you called MindSphere. So we are providing MindSphere as a platform as a service to customers. The customer can manage their data, their application on their own. Rest will be taken care by us, like networking, server, storage. So customers need not to worry about all this stuff. Runtime, middleware, operating system, virtualization, storage. Okay, so this is a platform as a service we are providing to customers. Now, infrastructure as a service. So infrastructure as a service are all those parties who are providing cloud. Amazon Web Services, Google Cloud, Microsoft Azure. So these are all biggest cloud providers. Okay, they are maintaining their data centers. Okay, they are thousands of square feet. They are maintaining this data centers. So Amazon Web Services, AWS, you can say AWS is the biggest cloud provider in the whole world. Then Microsoft Azure, then Google Cloud. Okay, Google. So these are all cloud providers who are maintaining their servers, data centers, you can say. So we have taken their services. Siemens is not maintaining any server. We have taken servers from these parties, Amazon Services and Microsoft Azure. Okay, clear? These platforms are clear? IaaS, platform as a service, and software as a service. Okay, now in market, hybrid models are also possible. Okay, so PaaS with SaaS also possible. IaaS with PaaS also available in market. So as you go or 10 years down the line or 20 years down the line, you will see hybrid models in the market. But these are the basics model which are present on which is a scheme on which all the platforms are working upon. Okay, fine.
Sir, I have a question.
Please.
So, how does a company decide which type of service it has to use?
Which type of this platform?
Yes.
See, as a Siemens, okay, as a Siemens now, my customer come to me and he wants to develop an app for his machine. He is a machine manufacturer, for example. I will give you a best example. When you go for a car, when you go to buy a car, now MG Hectare, you go to MG this company, and you want to buy a car, MG Hectare. Okay, so MG Hectare is connected to internet, right?
Yeah.
Now MG Hectare is a machine manufacturer. Okay, car is a machine.
Yeah.
So he's a machine manufacturer. Now for MG Hectare, you as a customer is selling that car, that machine to you. Okay, now you need to he'll ask you install an app on your mobile phone of your car. So whenever your car is having any problem, or for example, any less of any this air pressure goes down in your tires, or engine is starting, or engine is not healthy, or your fuel is beyond that level, okay, you get a pop-up on your mobile phone. Okay,
Yeah.
just
Okay.
imagine that thing. Okay, so
Mhm.
you as an end user, you are using SaaS model, software service.
Yes. Hmm.
Okay,
Got
MG
it.
Hectare, MG Hectare is using platform as a service because he is selling
Yes.
you a platform. MG
Mm-hmm.
Hectare will be maintaining your data, your car data. Okay, MG Hectare will be maintaining
Okay.
your
Got
car
it.
data. So apps
Yeah.
which you are using will be taken care by MG Hectare.
Yes.
Okay, so
Okay.
MG Hectare will be using a PaaS, platform as a service, and MG Hectare, the data which you are transferring from your car and to cloud, okay, that will be taken care by this Amazon as a service. So it depends on
Yeah.
MG Hectare, and it depends on MG Hectare which cloud he wants to use. So he go to Microsoft Azure, he may go to this AWS. So his choice,
Hmm.
MG Hectare choice. Okay, so
Okay.
you are a SaaS user, software as SaaS user. Okay,
Right.
MG Hectare is a SaaS provider क्योंकि आपको provide किया है उसने वो मॉडल, SaaS मॉडल provide किया है. ओके, एंड IAS ने अपना क्लाउड, अपने सर्वर्स दिए हैं MG Hectare को टू स्टोर द डेटा.
Yes. Mm-hmm.
क्लियर?
Okay. Got it. Yes. Thank you.
Okay. Boom, I'm having some problem in switching the slides. Now my slide is not switching forward. I don't know.
Click twice.
Uh-huh.
Reshare the content. Click on
So you
stop
can
sharing.
try resharing it. Yeah.
Click on stop sharing.
Stop
and then-
sharing
Okay.
and then again
It's okay.
reshare.
It's okay.
Yeah.
I think. Okay, so now we jump to MindSphere. As I said, it's a cloud-based IoT operating system. So it's a Siemens cloud, you can say, and meant for this IoT. So it's an operating system. Okay, so we call it MindSphere. Fine, right. So when it comes to MindSphere, as I said, it's an open PaaS, platform as a service. Okay, so before this, come to this first connectivity. There are three layers: connectivity, then MindSphere as a cloud itself, then it's apps, applications. Okay, nowadays you guys are in college and you must be using Raspberry Pis and this Adreno Shields. I hope you are all using all these things which are used in this washing machines, ACs. So it all these things come into connectivity. You need to first you need to connect a physical asset to cloud. So I need an interface. So Raspberry Pi, there are many, LoRaWAN, BeagleBone, and what else? Adreno Shields. Okay, so these are all come into connectivity. So I need to connect my device, my car, my AC, my machine first. So I need an interface so that I can transfer the data to cloud. So that layer comes into connectivity. So connect products, plants, systems, machines, and enterprise applications. Okay, so connecting your hardware to cloud comes into connectivity. Fine. Next layer, MindSphere. MindSphere itself is a cloud, as I said. Okay, so it's an open PaaS, platform as a service. So you can develop your robust industrial IoT solutions faster with global scalability. You can develop your own app. Okay, so nowadays what Siemens is doing in many universities, we are selling a developer plan, so students can learn app development. Okay, so they can develop their industrial app sitting in their colleges, just to know what when they come out from the college and join any enterprise, any factory, any MNC, whether it's Siemens, it's Allen Bradley, or it's Schneider, or whatever. When you go and join all these things, so you should be facing all these things. You should be handling all these things. So idea is to first prepare yourself in college. So how app development coming to process, how we develop app. Okay, fine. Then we move to applications. So we have various apps, industrial apps, not all these apps you download from Google Play. Okay, Google Play is commercial apps you use for your convenience. Okay, so these are all industrial apps. We are talking about industrial apps. Okay, when I am connect my machine, say packaging machine. Okay, the soap wrapping machine. My soap wrapping machine wraps hundreds of soaps per minute. Okay, and I sold it to HUL, Hindustan Unilever. So that machine, when give data to cloud, my machine uptime, my machine downtime, how much is it produced, how much it scrapped, all these data I can analyze on any app or on a dashboard. So seems good, no? You can see all the data, how my machine efficiency is, how my machine is performing, उस शिफ्ट में कितना काम हुआ था, फिर सेकंड शिफ्ट में कितना काम हुआ, कितना सोप्स या व्हाटएवर कोई भी प्रोडक्ट बना, इतने उस आई मीन शिफ्ट में इतना बना था, बट इस शिफ्ट में इतना बना. सो व्हाट वर द ड्रॉबैक्स, क्यों डाउन आया मेरा प्रोडक्शन. सो दिस काइंड ऑफ डेटा. ओके, सो वी आर टॉकिंग अबाउट डेटा. सो डेटा इज ऑयल फॉर 21st सेंचुरी. जितना डेटा मेरे पास आएगा, मैं उसको इंटेलिजेंटली उसको मैं एनालाइज करूंगा थ्रू माय इंटेलिजेंट एल्गोरिथम्स, है ना, एंड हाउ आई कैन सी और डिस्प्ले दैट डेटा इन फ्रंट ऑफ माय कस्टमर्स. फाइन. ओके. Okay, then now edge devices. So Siemens is also into edge devices, edge apps, edge management, edge computing. I don't know how many of you heard about edge computing. Edge computing is a method in which, rather than processing the data in cloud, sending the data to cloud, we process it at the edge. Okay, at the edge. Some customers say, I don't want to share my data on cloud. Okay, I don't want to share my data on cloud, and I have some legal restrictions. So what we give solution? Okay, sir, no doubt, no problem. We'll process your data at your edge. I mean, I'll put an edge device on your machine. That device will process the data and give you a analytics. So we have that solution also. Edge management, edge devices. Okay, best example of edge computing is your self-driven cars. Self-driven vehicles are totally dependent on edge computing. So you must say in 2040 or in 2040 or 2045, or I don't
Hello,
know, I'm
sir.
not sure, but yes.
Sir.
हाँ, राम
Hello, sir.
ओके, राम बोलिए.
Yes, I want to ask you
हाँ जी.
that मैं एक मान रहा हूँ जैसे CNC मशीन है
हाँ जी.
और मैं उससे कुछ जॉब प्रोड्यूस कर रहा हूँ.
ओके.
देन आपने अभी बताया कि जैसे मैं कहीं भी जो है उसका डाटा एनालाइज कर सकता हूँ, जैसे माइंड स्फीयर में सारे डाटा इकट्ठे होते जाएंगे एक जगह पे.
करेक्ट.
तो सर कैसे ये होगा, मतलब कितना प्रोडक्ट, मतलब वो जो है वेस्ट आ रहा है उसमें, फिर क्या यूज कर रहे हैं, समवन फीड देयर और हाउ दे आर कैलकुलेटिंग.
No. Nobody would feed there. I'll install one device.
Okay.
Connectivity. Okay, I'll install one device, one IoT device near your CNC machine. तो CNC मशीन में जो भी कंट्रोलर होगा, मैं वो डेटा लूंगा उस कंट्रोलर से. क्या स्पीड है, कितना बना हुआ है, कितना इसने आज मेरा टूल्स बना दिए CNC मशीन ने, कितनी देर वो ऑफ रही, वो सारा डेटा कलेक्ट करूंगा मैं. Then I feed the data to cloud, to MindSphere.
सर वो कैलकुलेट कैसे करेंगे?
What calculate? Which data calculation?
सर वो मशीनरी, जैसे जब सर जॉब हो सकता है फॉल्टी निकल जाए तो ज्यादा वेस्ट प्रोड्यूस हो जाएगा वहां पे.
Okay.
ऐसा भी हो सकता है ना सर, अप टू मार्क ना रहा वहां पे.
I understand आप कह रहे हो कि मशीन कैसे अगर मशीन कैसे बताएगी कि मेरे क्वालिटी मेरा जो रिजेक्शन है वो कितना है कितना नहीं है. सी, अगर मशीन डेटा नहीं दे पा रही है तो हमें उस मशीन को कैपेबल बनाना पड़ेगा. फॉर एग्जाम्पल, अगर मशीन को नहीं मालूम कि कितना स्क्रैप हुआ, मेरा टूल बनाया, मुझे वहां सेंसर्स लगाने पड़ेंगे. अगर मशीन को नहीं मालूम है कि कितना मेरा डेटा आज बना ओके थ्रू सेंसर्स और कितना रिजेक्ट हुआ, तो वो मुझे फीड करना पड़ेगा.
ओके.
Hi Vikas.
Got you?
हाँ, yes sir.
Hi Vikas.
Hello sir, hello.
Hi Vikas. My name is Kunal. Can I interrupt in between? I'm really sorry.
Please.
And I would like to explain a little bit on this what this question was about.
Okay.
I just missed ये question किसने पूछा था? If you can please come.
Ram Shankar.
Ram
Sir,
Shankar.
myself.
Okay, Ram Shankar, you have given a very valid question और जिसको विकास ने जो explain किया है is absolutely right. इसमें एक एडिशन करना चाहूंगा मैं यहाँ पे, बिकॉज होता क्या है कि आपका क्वेश्चन ये है कि मशीन कैलकुलेट कैसे कर रही है, राइट? कि उसने कितने प्रोडक्ट्स गुड फिनिश्ड प्रोडक्ट उसने प्रोड्यूस करे हैं, या फिर मशीन में अगर कोई प्रॉब्लम आई है तो वो कितनी देर की आई है, क्या उसके पैरामीटर्स रहे हैं. जो कि यहाँ पे हम सीएनसी की बात कर रहे हैं तो उस पर सर्वो मोटर्स यूज होती है, तो हम कैलकुलेट करेंगे किस आरपीएम पे मोटर वर्क कर रही थी, कितना टॉर्क था और किस टाइम पे कौन सी मोटर ने काम किया एंड सो ऑन. अलग अलग तरीके का डेटा है. तो आपका क्वेश्चन ये था कि ये डेटा का हमें पता कैसे लगेगा, मशीन बताएगी कैसे, राइट?
Yeah, excuse me, sir. Yeah, I'm sorry to interrupt, but I'm getting a request from participants to like use English only because some of the participants are from South India.
No
so they are
problem.
facing some issues.
No problem. No
Thank
problem.
you, sir.
I will just repeat it once again. The question was from Ramashankar Singh asking that how is machine calculating the data? How is machine calculating, like what was the revolution of the motor, how many hours machine has worked, what was the, if there was a breakdown, and how long was the breakdown, who was the operator, or any question, whatever parameters we are considering. So these are pre-written parameters. There is a program that is written in the PLC of the machine. Either if the machine is using a PLC,
Absolutely.
then there is a dedicated program which is already written. There is some logic which is written behind every calculation. So basically it is the human, or it is the programmer, the PLC programmer, who is writing the logic to calculate this data. This data is further saved into the DBs of the PLC. DBs, data blocks. If any one of you have worked on Siemens PLC. So DB is a data block wherein all data is stored. Now this data is fetched by these servers. Now they may use a mediocre software in place in order to transfer data from the machine to the server or cloud, whatever storage you are using. So this is how it is going. So the answer to the question is, it is pre-programmed how you are going to calculate each and every data. If
Correct.
I am able to answer the question in the right way.
Yes, sir, nicely. It was nice. It was nice explaining to Ram Shankar.
Thank you so much.
Thank you, sir.
Thank you, Kunal. Okay. Okay, Ram Shankar. So it's a job of PLC to collect all the data. Actually, PLC is the brain of any machine. So all the data,
Yes.
as Kunal sir said, all the data comes to this brain. PLC. So I will be taking data from PLC itself. Okay.
Yes, sir.
Now,
Thank you.
hope I am able to understand. I was on edge management. Okay, edge devices, edge computing. So, but a best example of edge computing or edge technology is self-driven cars. It's already in market in Chicago. So I was telling that 10 years down the line or 20 years down the line in India, when you book a cab and go to a cab, so it will be a self-driven vehicle. You go, you speak your OTP, and this vehicle will start driving. So chauffeurless vehicle will be there in 2030 and 3040. So this already happened. So whatever that driver is doing right now, feeding OTP and following that map. Okay, you have seen the driver has to follow that map in Ola and Uber. So that vehicle will follow the map. Okay, so for that, I need to process my data at the edge. So for that, at every 100 meters or at every 500 meters, depending upon the strength of the servers, I need a server. So to run that vehicle on Indian roads, this self-driven cars, I need a server at every 500 meters, okay, installed in between on roads, so that these self-driven cars can compute the data, can process the data at a very high speed. So I am processing my data at the edge of the network. Hope you understand the edge computing. Okay, so this will soon happen in India because it's already done in Chicago and all. Tesla has produced many cars, self-driven cars. Tesla. Okay, so edge computing is that. So right now here, customer says I want to process my data at my edge. I don't want to send my data, my critical data over to cloud. Okay, so that solution is also possible. So we have edge devices also, edge apps also, and we have to manage all these things. We have edge management integrated into the MindSphere. Right? Okay, fine. So right now, so Ram Shankaran, this is your this slide will give you answer of your questions. So these are all connectivity options Siemens is having. Okay, through which I connect your machine, your CNC to cloud. So the first row is hardware gateways, and rest 1, 2, 3, 4 rows are software gateways. We call it gateways through which I connect any plant, any machine to cloud. Okay, so above two, Mind Connect Nano, Mind Connect IoT 2040. These are all hardware gateways. Okay, and all below all these things is a software gateways. So there's a Mind Connect Edge Analytics, Mind Connect IoT extension, Mind Connect integration. There are different uses in different factories. Customer wanted my ERP data and SAP data, and every factory has SAP and ERP installed. So they want to integrate that data with MindSphere so that he can see all the data, all holistic data on a single dashboard. Okay, for that he has to buy this Mind Connect integration. Okay, Mind Connect IoT extension. Some customers might not using these devices, Siemens gateways. They are using what I said, Raspberry Pis and Dell Edge gateways. Okay, I mean non-Siemens gateways. So in that case, if customer want to connect to MindSphere, Siemens Cloud, then he has to buy this IoT extension license. Fine. Similarly, this edge analytics, if any customer want to analyze the vibration of the motor, okay, where the data is very dynamic. Okay, so for that we cannot transfer that data to cloud because data is very dynamic. They are changing at very high speed. So what we do that edge computing. We have to pre-process that data at the edge of the network and take decisions accordingly. For that, we need this edge analytics. Okay, and this Mind Connect is the API and library. If any customer is using embedded system, okay, he said, no, I don't want to buy any PLC. I'm using my embedded microcontroller. In that case, if that customer want to transfer data to MindSphere, for that he has to buy this Mind Connect libraries. Okay, so point is that idea is that connectivity is not the problem with Siemens. I can connect any PLC irrespective of brand. I mean, Aaron Bentley, Rockwell, Schneider, any PLC to MindSphere. I'm only concerned with data. Okay, fine. Now, as I said, MindSphere. So it's a platform as a service, as I said. Okay, so we are getting infrastructure support from Amazon Web Services and Microsoft Azure in India. In China, okay, we have Alibaba because in China, Amazon Web Services and Microsoft Azure services are not available. So in China, we use Alibaba Cloud. And in the rest of the world, we are using this infrastructure supports from Amazon Web Services and Microsoft Azure, as I said. So we are using infrastructure as a service from Amazon Web Services and Microsoft Azure. Clear? Mind apps, as so we have more than 50 apps available on this platform. Any customer can download as if you download the apps from Google Play. So customer can download these industrial apps for its use. Okay, so that are all chargeable. If any, there are many devices for CNCs. There are different apps are available. For if a customer is making packaging machine, then packaging for a packaging machine. We have an application for packaging machine also. Many applications are there. Okay, and the beauty of this platform is that partners and customers can also develop their own application. Okay, so if this, you can say this CSIO or any institution buy this Mindsphere developer plan, so the students can develop their own app on Mindsphere platform. Okay, fine. Okay, so these are all some IT security standards which Mindsphere is catering to. As I said, data is very important, customer and enterprises don't want their data to be leaked or any data breach. So we are using ISO 27001 and IEC 62443. These are all IT security oriented industry standards for data security. Okay, and data in motion, that means data from that gateway to cloud will be encrypted, will be 256-bit SSL TLS encrypted. Okay, so just to show to our customers that we are following all data security platforms. It's just a one slide. We have a full document when the customer asks for this data security, what all you are following for data security. So we share that format also with customers. Okay, fine, right. So now here comes some stuff which is for you. I mean, which is for college students, which is for institutions. So developer, operator, then user. This thing, this is the background of any application development. Okay, any application developer. Most of you all are from IT background, also from CS background also. I am from electronics and electrical. So I have not done many, I mean, hands-on on all this Python and Python, what else? Java. Okay, so these two languages are widely used for application development. Okay, so as a Siemens, we are selling these plans, developer operator plans. We call it DevOps. Okay, so but it's a general term. When you go to Google and type DevOps, so DevOps is a technology in which we have integrated development phase and operation phase of an app and combined it to save time. Okay, when you develop an app in a developer platform, so in developer you can test and you develop and test your application in developer plan. So you get a space in cloud, you get a 2 GB RAM space in cloud, in where you can develop and test your applications in developer plan. Operator plan, when you want to operate or when you want to sell that app. When we download apps from Google Play, so we are accessing the operator plan. Hope you understand. Just to give you a layman language, when we are downloading the app from Google Play, so Google Play, when we visit to Google Play, so Google Play is a operator environment in which from which we can download the app, use it, purchase it. So we need an operator platform. We cannot see developer platform. Okay, we need not to develop an app. We want to use it, we want to purchase it and use its functionalities. So whenever you go to a Google Play and see what apps are available, you purchase it, you use it, you operate it. So that comes into operator plan. Okay, and it goes to a user. Correct. Just to show what is happening in this application, we all using application. Okay, just to show you what in background what is all happening in this app development and app operation. Fine. So this is just IoT journey. So as I said, what you do in developer, then what you do in operator, and how user can use all the things. Okay, so in developer you create your APIs, you got access to developer cockpit for streamlined application and resistant validation. So one more validation, and as I said, that in developer you can develop, you test, you validate your application in developer plan. In operator plan you can publish applications to MindSphere store. Okay, so anybody wants to buy that app, you made an app, and then app was, I mean, really good, and anybody likes that app. Okay, so you can buy from that MindSphere store. That price and cost will be come to you. Okay, fine. So user, all the user who are using these apps, that comes into user portfolio. So MindSphere store for buying and valued application, connect to your enterprise systems and legacy databases. So if I develop an app for a machine, then first I develop it, test it, validate in developer cockpit. Then I move to operator where I publish it, I operate it, and the user will download it from MindSphere store and start using it. Okay. Same thing which I told you about developer. Okay, so you get a dedicated cloud foundry environment, okay, with predictable scale and cost, cloud native application development with any operating tool. So idea is that we are moving towards a future in which machine will learn. Okay, so we are entering a future where machine will tell itself, machine which will heal itself, or machine will tell you that this is my life. Either do a maintenance or I will fail, or in a week time I will fail. So when a machine get fail, the enterprise or any industry will cost a huge lot of this loss. Okay, so production loss is a money loss for any industry. Okay, one thing more. This machine learning. When I come to machine learning, there are various algorithms. We have used state-of-art all machine learning tools, which is integrated on MindSphere. Okay, so TensorFlow, for example. TensorFlow is the right now best this open environment for machine learning from Google. So we have integrated that with MindSphere. Okay, to give you a predictive analysis, right? To give you a machine learning. So the more data you give to your machine, okay, the machine will learn. For example, whenever you go to Google search engine, you type something or any search. I mean your Facebook, or your YouTube, and you search something. Next time when you search, it will give you all your results as per your searches, previous searches. It happens, right? It happens with all of us. So that thing. So machine is learning. Machine is learning your preferences, your search preferences, and giving you data which you are looking for. Okay. Similarly, is here. If my machine going to break down, so that algorithm which is there in MindSphere will stamp it. 1 year later, this machine went to break down because of this. Now, right now, in current scenario, if that situation again arises, that machine will give you a pop-up that the same thing is arising which was happened last year, rectify it, or I'll go into breakdown again. So you are giving data to your machine. It is called artificial intelligence. Okay, so this IoT machine learning is a journey towards artificial intelligence. So artificial intelligence is an endpoint. Okay, so endpoint. We have not reached yet to artificial intelligence. We are moving towards artificial intelligence by doing all this stuff. Deep learning, neural networks. Okay, neural networks are now in very hot in market right now. So we are evolving. Okay, fine. Okay, this was my last slide.
Hello,
I
sir.
think I'm on time. Right. Please.
Sir.
Any questions?
Hello. हाँ sir.
हाँ Ramshankar. Audible.
As the data is collected in the mind sphere you have,
Yes.
and then how you are going to analyze those data so that you are going to able to pop up to a particular machine.
See, as I said, this various algorithms are there. Predictive algorithms, predictive learning algorithms are there in MindSphere. Okay, we have integrated it. MindSphere is a cloud.
Practical.
Hello. Sir.
Hello.
Hello.
Ramshankar, audible, please.
Yes. If you will elaborate with a with any of a practical example, then we will understand it easily.
Practical example.
You can take any of them.
Vikas, Kunal here. Can I give one example?
Please,
to
please. Yeah, help me out.
I am trying to help because I have been working in industry for last 10 years.
Okay.
So I have been working on this industry 4.0 concept and industrial automation for last 10 years. I know what a good reality of the machines and this automation.
Right.
So I am just trying to extend my help. Okay, so Ramashankar, your question is if we can explain, if Vikas can explain to you by giving a practical example how data is collected, right? So I will give you an example, and this example is coming from an industry wherein I have worked, and I have designed the program in the PLC myself for this kind of an application. So what happens is we have written an algorithm. Basically, not an algorithm exactly, it is a PLC program we have written for collecting certain type of data. Now this data includes raw material feeding data, right? What amount of raw material is fed into the machine? Now I have written it in such a way that if the machine is working in automatic mode, if you know about the process of a machine, it works in manual mode and in automatic mode. So I want to calculate what was the time in shift. There are 3 shifts, shift 1, shift 2 and shift 3. Right. So I want to know in shift 1, what was the total running hours of the machine? What was the total break time on the machine? What was the total breakdown time on the machine? Who was the operator? Who was the quality in charge? Who was the production in charge? So I have written a program in such a way that machine is now calculating what are the number of goods produced. For example, it is producing 200 pieces of a finished good product. And if you take an example, I am taking an example of a jam that we eat at home. Everybody knows about a fruit jam that we eat at home. So a machine is manufacturing jam. I want to know how many bottles of jam this machine has produced in shift 1. The target was 300 bottles, but for some reason it was able to produce only 200. Why was the gap of 100 bottles? So this is the data that you need to analyze. Now, if you know why 100 bottles were produced less, so you will be able to produce 300 bottles from the next day.
Yeah. Sir, we are here optimizing the production that you had said.
Hello.
I request one at a time. Yeah, Manjunath, you can go ahead. Yeah.
Hello, this is. Yeah. Hello, sir. It's a nice presentation. I just want to know about the edge computing. Actually, you said that the data is very dynamic. The vibrational signals and the force signals which we are getting at the outer end, which are very complex in nature.
Correct.
Hello.
Yeah, audible.
Am I audible?
Please.
Am I audible?
Audible.
The thing
Please.
is, how can you compute it at that dynamic? Actually, those processors are non-linear and dynamic, highly non-linear and dynamic nature. How could a system of small Raspberry Pi can able to compute such a strong computations of having force, vibration, acoustic signals at the end stage? I mean, what is the interface between them to do that process? Yeah, thank you.
See, we have a solution. Siemens is a hardware. I think somebody has unmuted his mic. Fine. So first of all, I'll not use Raspberry Pi. My voice is still echoing. Okay, fine.
I request all the participants to mute yourself. Yeah. Please mute yourself, everyone. Yeah.
Okay, so first of all, I'm not using Raspberry Pi. I'm using an edge device, okay, which I'll connect to that machine, to that PLC. Okay, we have a module to sense this all vibration.
I'm asking about the edge device itself. Yeah, how could it be able to calculate this complex? Actually, if I got a flankware on that machine and my machine is going in order, I mean there is some abnormality is there. I mean, how could it detect? I want to know that end part of detection.
End part, I mean, see, to sense that vibration, first we need to install some vibration sensors. Okay. So, for example, we have a PLC and we have a module. Not getting that name. We have a module which will be fixed with the PLC.
Okay.
That module is having 4 sensors, and you have installed that all sensors on the vibration points. All the data is getting first to PLC.
Okay.
Okay. Then PLC is connected to that edge device.
Yeah. Yes. Okay.
Okay.
Yeah.
So I need a PLC.
Okay. The PLC will do the interface work for us. Okay.
Right.
Okay.
So that due to that dynamic data in nature.
We have 3 different. Okay. No, we have 3 different accelerations and more acceleration sensors. Yes, ma'am.
Yeah, Manjunath, I request you after saying question, kindly mute yourself. Yeah. After saying question, kindly mute yourself.
Okay, sorry.
Okay.
Yeah, it will be better.
Okay.
Okay, Manjuda, are you yeah, please.
Okay. I mean, I want to know if I have different acceleration signal, different force signals, one signal and signal. I have signals.
So you are not audible.
Hello?
Now your signal is weak, I think.
Sorry. Hello.
Hello, Manju.
Hello.
Please.
Hello.
Carry on. Manjunath, you are not audible, Mr. Sharma.
So we can go to the next question from Aryan. By the time Manjunath will connect to me again.
Okay, fine.
Aryan, after saying question, kindly mute yourself. Okay?
Yes, ma'am. Yes. So, sir, my question is like you have mentioned that in the edge computing, due to non-availability of many servers that being placed of 500 meters, सर मैं ये पूछना चाहता हूँ कि क्या उस केस में सर्वर्स को जैसे आपने एग्जांपल दिया सेल्फ ड्राइविंग कार्स का
राइट
उस केस में क्या सर्वर्स को उन कार्स के ऊपर ही लगा दिया जाता है और वेदर सर्वर्स आर इंस्टॉल्ड एट अ वेरी डिस्टेंस ऑफ 500 meters.
Right. See, this is just my example to make you understand that data processing. In that case, data processing will need to be fast. Because a self-driven vehicle has to take decisions very fast. Need to turn, need to stop, need to brake, need to accelerate. So for that, data processing should be very fast. I cannot send that data every time to cloud because sending data to cloud will increase latency. Latency is defined as I'm transmitting data from one point to this another point, and from that point back to the same point, back to the source. That defines the latency. Okay, so I cannot handle that latency when self-driven cars will be on road. So for that, I need to process the data at the edge. Okay, whatever will be the, the strategy for that. I just give you an example to make you understand what the edge computing is. That I need to process the data at the edge. I cannot send all the data to cloud. So for that, I need to install servers at roads. Okay, I need to install servers at every 500 meters, or so example 200 meters. That was a vague idea just to make you understand, because every time I cannot send data to cloud. The car, that vehicle will not move, will not achieve that speed. So just to give an example, what the edge computing is, processing data at the edge. No need to, no need to send all the data to cloud because it increases latency. Latency बढ़ेगा, speed भी कम हो जाएगा for any process. For any process.
Sir, what this particular word edge means? मतलब हमने क्या कोई priority order decide करते हैं इस particular process?
Edge computing, EDGE, edge.
इसी edge word का क्या मतलब है कि remote servers जो है वहाँ पर हमने priority order पर डाला.
Edge means we are processing the data at the edge of the network. At the edge of the network. I mean near the network. We are not, right. We are not sending data to cloud for processing.
Okay, sir. And sir, आपने थोड़ा सा बीच में deep learning and neural networks का भी description.
Right.
Can you please throw some light on both the topics, like how they are emerging and what is being discussed in both the topics?
Machine learning is another subject. We'll take for machine learning. You want slide on machine learning, not slides. If you have any question, you can ask, because if you have any question, any silly question in your mind, you can ask it what exactly happened. There are many algorithms. There are 3 types of machine learning. One is supervisory, one is unsupervised, and one is clustering. So it is all about data. So like data is coming now. Data is coming. A very raw data is coming. Now I need to first cluster it. For example, I'm fed with the data with 3 types of balls with 3 colors. Okay, and all the balls are thrown to me with all 3 colors. So say 100 balls. Okay, so first I need to cluster it. I'll separate same data at one place. So red balls at one place, yellow balls at one place, green balls at one place. It's called clustering of data. Okay, so this is how data and machine learning comes into picture. How I manage, how I read, how I use that data to take corrective actions. So as Mr. Kunal said, that for that various algorithms are written on any platform. So you need not to reinvent the wheel. Okay, so right now, machine learning is a very mature state. You need not to learn how to cluster, which machine learning I should use for this data. Many algorithms, as example, I said TensorFlow, from Google. It's the best known platform right now. The best platform from Google for machine learning, for deep learning. So if you have that product, even Siemens has not, invested in implementing and coding all these things. Siemens buys simple from Google. Just give me the TensorFlow, and he installed it. He's integrated in MindSphere. So whenever the data thrown to MindSphere, okay, that algorithm will start accessing all these things. That what kind of data points are coming. Okay, they will start relating the data points. What is the relation between the data points? So this thing. So I think I'm able to just give you a short overview. What is machine learning all about? Neural network all about? App.
Yes, sir. And sir, I usually develop an app in Android Studio. So for example, like I use MindSphere as a cloud. So
Okay.
does this MindSphere also provides the service of creating an app?
Aryan, your last words, I lost your last words.
Okay, I will repeat the question. Suppose I create an app in Android Studio.
Okay.
So I'm thinking like I should use MindSphere as a cloud for storing my data. So does MindSphere has an integrated option of like I want to develop my app on the MindSphere as well.
Correct. You
मतलब
can
क्या उस
develop your
केस
app.
में MindSphere के अंदर कोई ऐसा ऑप्शन भी जिससे हम अपनी ऐप को क्रिएट कर सके rather than using Android Studio?
Android Studio. Okay, sir. You were comparing Android Studio with MindSphere.
Yes, sir.
Okay. Nee, I don't know about Android Studio. Android Studio is generally used for these commercial apps.
Okay,
but if you want to develop an app, any commercial app on MindSphere, that is possible. I'm not aware of this Android Studio. Okay, but if you want to develop an app on any Android platform or iOS platform, that is possible with MindSphere developer plan.
Okay, sir. Means MindSphere also provides the availability of commercial apps as well.
Right.
Okay, sir. And sir, why should I directly use MindSphere rather than using Google or Android server?
See, MindSphere, now good question. When we talk about MindSphere, we are mainly talking about IIoT, Industrial Internet of Things. We are maintaining all IT security standards, data security standards, world level data security standards that you might be not using when you're using commercial apps. But when it comes of industrial apps, when it comes on a machine app, okay, then data cost everything. Data is everything. I cannot. I mean, I cannot give a chance to any hacker or any you can say any IT expert to breach my data, to steal my data. I cannot take chance. Siemens cannot take chance. Siemens is a brand value, obviously. So Siemens cannot take chance that his data gets stolen or its data get shared by any industry. So we need to adhere to strict guidelines when it comes on MindSphere. As I showed to you, we are using all IUC standards or IEC 62443 standards for data security, for data integrity. But when it comes on IoT, as you are Android and all, so that is not a very, a critical thing to talk about. When I talk about MindSphere and Siemens standard, we came across human life also because machines are connected to MindSphere. So if I hack or if I steal that data, have you seen that movie, that Bruce Willis movie, Die Hard 4? RM?
No, sir. No, actually, I
So your homework, so your for tonight homework is watch that movie, Die Hard 4 from Bruce Willis.
Sure.
Okay, so you'll see when it's a all based on IoT. So my gas connections are connected to internet, my traffic signals are connected to internet, and my power grid are connected to internet, and I am controlling all these things sitting in a point in Bombay. And I think in Bombay gas connections are already connected. If you are out of the balance, your gas connection will turn off, and as soon as you pay the bill, your gas will be, these commercial gas will be turned on. Okay, so that thing is already gone. Already on. Okay, traffic lights will be connected to internet soon. So the traffic guys will be controlling the whole city traffic sitting in a control room. Okay, power grid will be connected to internet. So when these things come to a wrong hands, or when these things are being hacked by any hacker, what havoc he can create in the city. So that movie is all about.
Sir, means in a correct taking the MindSphere as an intermediate between Amazon and the user. The priormost duty is to the data security now.
Data security, IT security, internet security. Correct.
Okay, sir. Thank you so much, sir.
Right.
Hello.
Yeah. Hello, sir. Can I continue? Hello, sir. Hello, this is Manjunath. Can I continue?
Yeah, Manjunath, you can ask first, then Parihar sir can ask. Okay,
Haan, ma'am.
one by one.
Yes. Okay.
Yeah, Manjunath, welcome back.
Yes, yes. The last question I was is, sir, based historical data, you are just telling previous on the historical data, I could able to predict the present future. I'm asking for the future,
Correct.
future cutting.
Okay.
If I have a tool where I know the historical tool where history, I want the future tool where history. Whether with this software is it as clear that? So, yeah.
I still lost your
Yes, sir.
last
About
sentence.
the future data, I'm asking.
You mean to say prediction?
Future data. How could we calculate the future where?
Predict
Yes,
the
yes,
data.
yes. Future where prediction, I would say.
Okay, अच्छा आप
Yes. Future prediction.
you have
With
heard
the
about
historical data, I want the future prediction.
right. अच्छा you are well aware of this weather forecast. How this happens? Have you just thought of it? How we do this weather forecast? And 80-90% nowadays weather forecast is correct.
Yes. Okay, sir.
Okay. So what happened?
Yes,
happened?
I am clear about the forecast.
Right. So what happened in the background when you give data to machine is continuously learning, continuously recording that data. Okay. Any error signal it receives. For example, your machine. I think you have not unmuted your mic. First, unmute your mic. Right. Now it's fine. Okay, so when I was talking about when you are giving data to machine, for example, I'll give you I give you in layman language. I have get connected with machine for 1 month. Data is coming to 1 month. Data is coming to that machine from last 1 month. It will not predict. It will not give you the insights. Okay, so as per our strategy, at least I need that machine to be connected for at least for 1 year, so that in 1 year, when that data is fed to the machine, that OS, or you can say that algorithms, only after that, machine is capable to take decisions. So that is not. I mean, 1 month data is useless. I need at least 1 year data to fed to the machine. Okay, to fed to the algorithm. Algorithm will learn the data, will take the data, will read the data. Okay, and take out the data points. Take out the you can say data pattern. What was the data pattern came to me in last 1 year? Okay, it will read, it will learn. Now after 1 year, if the same pattern happens, okay, after 1 year, if the same pattern happens, that algorithm will tell you the same pattern happened 1 year before. So, before I go, before the machine go into a breakdown, because same pattern, I saw same pattern, I realized I felt the same pattern before in last 1 year, and if you not correct all these things, the same thing will happen. So it's all about data pattern.